Hello everybody. We are going to do merry-go-round physics again this week. Here's the setup I have. I have a little block, the green little block that you saw 2 weeks ago is sitting on a board attached to the merry-go-round. And I have some other equipment attached here, and I use this so I can time some things, and I will talk about that more when I see you in person. But what I want you to know before you come to the lab, in fact, what I want you to tackle is I want you to figure out at what rate of rotation, what period of rotation, and remember what a period is. That's the time it takes for the merry-go-round to go around once. I want to know what is that period at which point that block comes off of the other brown board. Remember 2 weeks ago, we spun this with the block on, and eventually it fell off the back of the merry-go-round. Well, the same thing is going to happen here. I can demonstrate this. If I start spinning this, I can see my little block happily sits over there, and if I speed it up more and more, I'm undecided whether I'm going to film this completely. But when you are here in lab, I'm going to speed this up more and more and more. And at some point, that little block, which is sitting there very happy right now, is going to come off the end. And if you remember 2 weeks ago, we talked about the physics of why it came off. Now I want us to actually make a prediction. And this is indicated in the lab that I'm going to give you, but I will just mention it here using words. So remember, as this merry-go-round goes faster and faster, there is a greater demand on the friction between this little block and the board that it's sitting on. And that block will come off when there isn't enough friction to support the acceleration of going around in a circle. And I want you to use that particular point, recognizing, okay, the block comes off when I run out of friction. So I want you to apply Newton's laws to this block. You should look at how many forces are acting on it, particularly what is the force supporting the acceleration as it travels in a horizontal surface, circle, and that is friction. And at some point the friction runs out. And I want you to look at Newton's laws at that particular point when friction runs out. And from that, you can figure out what must be the rotation rate. And I'm looking for, in the lab is called T, big T. That's the period of rotation, because as I start to spin this, the period of rotation is slow. It might take 15 seconds to go around once at first, and then it's 13 seconds and 10 seconds. And at some point, at some rotation rate, which equates to some speed of the block, it'll actually come off. And I want you to calculate that. And I'd like you to actually give a try to solve this before you actually come to the lab. That's true. That's what I want you to do. All right, I think that's all that I'm going to say. Again, here is the setup. You'll see just simple diagrams of this when you look at the lab. But what it is, just to remind you again, is this little block sitting here. Let's put it here, and at some spinning rate, some period of rotation, it will come off. And I want us to predict what speed that's going to come off based on Newton's laws. And there'll be actually two things that we have to measure to get to there, but I think it's actually pretty exciting physics. All right, I'll stop there, and I will see all of you in a couple days.